here there is some properties of logarithm. These all properties is obtained from the exponential function properties, okay? So for example, here, in the first one, b to power 0, for example, we don't know this value x, okay? We don't know, let's write the x, okay, let's write here. I will not prove all of them, but for some of them, let's talk about. For example, our aim to calculate this value, we don't know this value, okay? Let's say this is x, okay? So what we obtain, b to power x equals 1. For all b, which power equals 1? b to power 0 equals 1, okay? If b is 5 to power 0 equals 1. If b is 6 to power x 0 equals 1, or b is 1 over 2 to power 0 is equals 1, there is no problem. So b can be negative also, there is no problem. But if b is 1, for any x is correct, okay? So if b is different than 0, x equals 0. If b is different than 1, sorry, x equals 0. So this the answer of this question is 0, because b is different than 0. So the reason b is not b, if b is 1, the x is not important here, okay? So for logarithmic function, b never be 0, okay? Sorry, b never be 1. Also for the exponential function, we set the similar thing. B is different than 1 and different than the 0. If b is 1 and 0, we have a constant function, okay? And the constant function is not 1 to 1, so there is no inverse of this constant function. So for the base b, b cannot be 0 and b cannot be 1, okay? But here b's are positive real number. B cannot be negative also, sorry, because minus 1 to power x is not definite, okay? Let's recall the exponential function. When the exponential function valued, for example, it's not written here, sorry. So y equals b to power x exponential function, b should be bigger than 0 and different than 1. If b is 1, it's a constant function, because if b is 0, again, it's a constant function. B cannot be negative because minus 1 to power 1 over 2 is not meaningful, it's not definite, okay? So by using the properties of the exponential function, you can prove these all properties, okay? For example, let's look to 6th one. M over n equals logarithm base b m minus, so this should be n, m minus logarithm n, okay? So let's try to prove this fact, okay? Let's say this is x. So what we obtain, m over n equals b to power x, okay? Let's say this is, for example, let's say this is x0, this is x1, this is x2. So from here, m equals b to power x1. From here, here the base b again, sorry. So n equals b to x2, b to power x2. Okay, so if you check the m over n, what is m over n? B to power x1 over b to power x2, so which is b to power x1 minus x2 by the properties of the logarithmic function. So here, by taking by using this definition, logarithmic definition, this definition, okay, we can say that logarithm base b over m over n equals x1 minus x2. What is x1? X1 is this one. Actually, this part is not necessary. Okay, so x1 is logarithm base bn minus x2 is logarithm base bn. So we found our properties as you see. Okay, this is the one properties of the logarithmic function. So we have several properties of logarithmic function. You should know all of these properties. Okay, so let's solve this question by using that properties. I will show that each properties at each step. Here, our aim to calculate this one. Okay, we can write this h as a power of u. Okay, let's find that properties. Where is this properties? This one. Okay, p can be written as a power of the m if this is a factor of the logarithm. So by 7, 3 to logarithm base 3 u to power h. Okay, and logarithm 3 of 3 to power logarithm 3 can be cancelled here. Okay, by the using logarithm, let's find this properties. This one. Okay, base logarithm base can be cancelled, so this is equals to x. If x is bigger than 0, of course here it should be bigger than 0. So this equals by the which properties, 4 properties. Okay, by 4 equals u to power h. So the answer of this question is u to power h is the answer of this statement. So by using that properties, you can simplify. Okay, please solve several questions about these properties from the study plan, because there are several alternatives. Okay, here. Okay. For the following equation, find x. Let's look to the second question. Now, I will use some other properties. Here, to the power 2 over 3 can be written the power of the 64. Okay, let's write. Left hand side, I keep left hand side. Logarithm base b of x. Logarithm base b 64 to power 2 over 3 plus logarithm base b, again we can write this as a power of 9, logarithm base b 9 to power 1 over 2 minus logarithm base b 12. Okay, there is no factor, so I don't make some arrangement. So you can calculate cube root of the 64 here. You can calculate this cube root, most probably. What is 62? 2, 4, 8, 16, 32, 64. So to the power 6. Okay. So here, to the power 6 to power 2 over 3 plus logarithm b. This is a square root. So which is equals 3. Direct I will write the 3 minus logarithm base b 12. Okay. So here, by using the properties of the exponential function, exponential value, okay. Oh, sorry, not this color. This equals to the power 6 times 2 over 3. This cancelled, which equals to power 4. Okay. So we reached this result. Logarithm b to the power 4 plus logarithm base b 3 minus logarithm base b 12. Okay. So right hand side, this is product rule. Okay, this is product rule. This is the relativity division because of the negative. But let's calculate step by step. By product rule, what is the number of product rule? Let's look here. 5. Okay, so by 5, this equals logarithm base b to the power 4 times 3. Okay, minus logarithm base b 12. If we use the quotient rule for these two summation or subtraction, which is by 3, okay, by the 6, for 6. Oh, sorry, this is the 6 properties. Okay, by 6, we can write logarithm base b to the power 4 times 3 over 12. There are some cancellation. That's cancelled. This is cancelled. We have 4. This cancelled. We have 2, 4, 8, 16. 16 over 4 is 4. That's correct. So right hand side of the equation is logarithm base b to of 4. Okay, logarithm base b of 4. So what we have, left hand side is logarithm base b x. So here let's write logarithm base b x equals logarithm base b 4. So by using the last properties, as I remember, let's look here. Yes, by using these properties, we can say that x equals 4 because bases are the same. Okay, here if the bases are the same, you can say that m equals n. So here by the properties, which properties number is 8? By the properties 8. Okay, by properties 8, x equals 4 because bases are the same. So x equals 4. So this is our answer. Okay, let's look this question. Graph the equation below by converting the exponential form first. Okay, then we choose the graph. Graph the equation. Below by converting the exponential form. So it is inverse function. We will use that one. Okay. So what is the exponential form? Actually, we have another alternative also, but here 3 to power y. Actually, according to this recommendation, I will sketch equals x minus 3 to power y. 3 to power y equals x minus 3, or x equals 3 to power y plus 3. Okay. But this is not our function. We should interchange the x and y because here this is a function of the y. X is a function of the y. So if we sketch this graph, okay, this is directly graph of this function, but it is not our familiar form. So we will sketch the graph of the inverse function. Then we will take the symmetry about the y equals x axis to find the graph of our function. Okay, so this implies y equals 3 to power x plus 3 equals, this is the inverse of the x. Okay, if this is f of x. So what is the graph of the inverse of this? Let's sketch. 3 to power x graph is this one. We shift to 3 unit. This is 1. Okay, this is y equals 3 to power x. We shifted 3 units, so we obtain this graph. This is 0.4. Okay, and now we take the symmetry to find the graph of our function. So the symmetry of this function will be like this one. So if this is passes through the 0.4, this is passes through the 0.4 again. You can verify if x equals 4, this is 1. So ln 3 of 1 is 0. So y is 0. This is correct. Okay. So the blue graph is our graph. So this is not correct. It is left side of the y-axis. It seems correct. Okay. It is similar to our graph. It is not correct. Our shape does not like this one. Also, this is not in the domain. Okay. X should be positive. Actually, x minus 3 should be positive here. X can be, yes, x should be bigger than 3. Here, x should be bigger than 3. If x is less than 3, it is not meaningful, okay? It is not the correct. So x equal to 3 is our vertical asymptote. So again, anyway, this is, part B seems correct. Part D seems the graph of the x time exponential function, okay? So here, our answer is part B.